So this is 8.1 number 19, and this is a tricky one. Okay, so again, please take your time to work through this. I'm going to show you how to do it. There are different ways you could kind of approach it, but I want to try and just give you, I guess, the way that I would maybe expect you to think about this. Okay, so let's read through real quick. First, the formula for the Richter magnitude, that's the Richter scale, you know, for earthquakes and that, is m, that would be the value, equals the logarithm of a, the amplitude of ground motion for the actual earthquake that's being measured, versus, or compared to, or divided by the amplitude of a standard earthquake. So this is all very, what's a standard earthquake amplitude? Well, the ratio is compared to sort of your standard or average earthquake. So as this value grows, it's larger than what would be a standard. So in 1985, an earthquake with a magnitude 6.9 on the Richter scale was recorded in the Nahanni region of the Northwest Territories. The largest recorded earthquake in Saskatchewan occurred in 82 near the town of Big River. It had a magnitude of a whopping 3.9, okay? Which is pretty small, but still, we don't get much around here where we live. How many times as great? Now here's what's important. How many times as great as the seismic shaking of the Saskatchewan earthquake was the Nahanni earthquake? So how many times bigger is this versus this? And of course, you wouldn't just do 6.9 divided by 3.9, because that's just this value right here. Instead, you would have to consider this value comes from a logarithmic statement, okay? So if you did 6.9 divided by 3.9 and got that answer of 1 point whatever, what that is, it's not correct, okay? Because it's on a logarithmic scale, okay? So really the next number up would be closer to 10 times, right, on a logarithmic scale. But anyway, so this is what we're going to do, okay? We're going to take a look at this, and we're going to say that a 6.9, okay, a 6.9 comes from this log of, now the A is going to be the amplitude of Nahanni, so I'm going to put A n over A0 or A naught. That's where the 6.9 comes from. The 3.9, okay, comes from the logarithm of the actual amplitude at, what are we going to call this? Just S, Saskatchewan, okay, over A naught, okay? Now this is a log statement, so I can rewrite this as an exponential statement. This is a base of 10 here, right? So this could be 10 to the power of, let's do the 6.9 one first. 10 to the power of 6.9 is equal to an divided by A0, okay? And 10.3, or 10 to the power of 3.9 is A of S over A0. So I'm just changing the log formulas here into an exponential statement. Now we're getting close to be able to compare these numbers, because if you consider that both of the AN and AS are being divided by the same thing, you really can just, you know, compare the AN and the AS. Now, I would suggest that this A naught, let's say it's 1, or whatever it is, they're both being divided by the same thing. So really, you could let 10.69, 10 to the power of 6.9 equal your AN, whatever that is, and the 10 to the power of 3.9 as AS, whatever that is. They're both being divided by the same thing. You could multiply both sides and blah, 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 but okay, which is fine. But let's just say they're roughly equal to whatever this is. Because all we're doing is comparing, so I want to know what AN divided by AS is. And that's really going to be 10 to the power of 6.9 divided by 10 to the power of 3.9. Okay? You're just relating the size of the magnitude of these earthquakes. And so really, this is now your answer. When you simplify this, this is 10 to the power of 6.9 minus 3.9. Do you guys know that log property? Or actually, it's not a log property, it's an exponential property. Remember, you have the same base, and you're dividing them, so you subtract the exponents, right? Remember that, grade 10? And so this really, the answer to this is 10 to the power of 3, which means that the ratio of AN divided by AS is 1,000. So the 6.9 earthquake in Northwest Territories is 1,000 times larger than the one in Big River, Saskatchewan. So it's not 1 point something larger, you know, it's 1,000 times larger. So that's how logarithmic scales kind of affect there.
Why didn't we just take the difference of 6.9 and 3.9 that was given in the equation?
Yeah. Well, you can't just take the difference here because that's 3. So the answer is not 3. The answer is 10 to the power of 3, right? So you just have to be careful. You have to understand that these come from log statements. Now, listen, it's easy to go from the answer back to the question and say, oh, why didn't we just do this? The problem is with that, right? It's like, why would you do that? You can't just look at the answer and say, oh, we just subtract the exponents and then take it to 10 to the power of that difference. Okay, but you got to work backwards and work out why that's the case. Do you know what I mean? So yes, we are subtracting these numbers. We're taking the difference of these numbers, but because we have to understand that because they come from log statements, so this is actually 10 to the power of 6.9. And this is 10 to the power of 3.9. So over the years, I've assigned this a number of times. This question, it trips up students for that reason. So please remember that a log statement can be rewritten as an exponential statement, which is what you have to do for this one. Okay, any other questions?